Hello everyone, it's December 6th. Alright, I want to get back to the Python a little bit. So I think, every day we have, we do about 2, right? So when we do about 2, what we will do is we will do 1 in Java and a 1 in Python, at least for now. And we'll see how it works. I kind of haven't done Python in this for a while. I feel like I'm getting less practice. All right, largest odd number in string. You're given a number string representing a large integer. Return the largest valued odd string integer, that is non-empty, or an empty string if no odd integer exists. A string. So we basically return a substring that is the largest. Oh boy. Well, if the last one is an odd, then yeah, there you go. You have it. And yeah, I mean the front doesn't really matter that much. I think it's just you go from right to left to find the first one that is an odd, and then you just claim that. Anything starting from the front to this will be the largest. Nobody will be larger than that. Okay, let's get this a shot. What are we returning? Oh, returning a substring. Oof. I think I forgot how to do substring again. It just, I never remember the syntax. It's really, really bad. All right, anyway, so we can say what? Int I equal to num dot length -1 while I larger equal to 0, right? And num dot char at I minus 0, right? And we can go for, we can do mod 2 is equal to 0. Or we can do fancier, right? We can do fancier. We can say fancier is this, right? If this is equal to 0, then I minus minus, right? Then we come out and we say if I is smaller than 0, then we will return. Oh, the hell? What was that? Oh, this, right? Otherwise, we'll return. I probably can do. Hold on, let's do this. Return. I say I smaller than 0. Then we do the empty string. Otherwise, we do num dot substring start to end. So we get I plus 1, right? Okay. Alright, we'll give this a shot. Looks good. Let me just how about we just do this? I think it's right. Oh, that's not what we want. What the hell is this? Okay, it's not too bad, huh? Not too bad. All right, so we can say LeetCode. I don't really care that they have easy question or difficult question. We're gonna do at least one medium, right? What do we say? We say, man, I got my new chair, but I'm not comfortable. Maybe I think the chair needs to get a bit higher. Oh yeah, this is better. What do we say? We say go from right to left and find the first digit that is odd. The largest odd number starts from the front and ends at that first odd digit. Oh shoot, what the hell is this? It should be 7. Hold on, did I mess it up again? Dang it. Ugh. Alright, that's fine, that's fine. We just need to ST this one again, so tomorrow we won't make the same mistake. Alright, so that's that. Done with this. Count 0 request servers. You're given an integer and denoting the number of servers and a 2D array logs, where logs I is server and time, denotes that the server with ID receive a request at time. You're also given an integer x and a 0 index integer array queries. Return a 0 index integer array of length queries, where array I represents the number of servers that did not receive any requests during. Then one more time. Return an array where array I represents the number of servers that did not receive any requests during time interval queries I minus x. So from x minutes, let's say x is minute, right? X minute before up until, so the past x minutes. The time intervals are inclusive. All right, so this is something gonna be very interesting. All right, so we have 3 servers, right? We have server 1, so we probably should sort logs. That's what I think. If we sort based on the time, right? So if we draw this, we have 1, 2, 3, 4, 5, and 6. So I hear server 1, I hear server 1, I hear server 2. But n equal to 3. So in total it's 3 servers, but only 2. So query 0. So query equal to 10 and 11. So the first one we want 5 to 10. How many? How many servers did not receive? So from 5 to 10, 1, right? Because we have 1, 2. And the second is from 6 to 10. Oh, shoot. From 6 to 10. If we go from 6 to 10, that is 2. So the number of servers, maybe we can do like a prefix sum-ish type of thing. So when you query a range, so you know how many, let's say from start all the way to 6, right? So from start to 3, what is n? N is 10 to the 5th. And I guess it's fine, right? So in this case, not n, log length. No, that's not what you. Log length is 10 to the 6. Ugh. 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 6. And actually it doesn't work because these two are the same. Okay? These two are the same. Um, maybe it does, right? Maybe it does. So what we sorted, right? And after we sort it, we can count the number of servers that is that did receive a request. So we'll start with in front will be 0, right? In front will be 0. So we'll have a 0 time, okay? So we'll have a 0 time. So we sort the logs, and then we have a 0 time, okay? And we'll have time, so it'll be a tuple, okay? 0, 0 here, and this will be time, be 1, be 5, 1, and 6, 2. Right, so all the way to 6, we have 2. And we do the last one, it's a 0. So we do, no, not 0, it's the number, it's 2, right? So the biggest, 10 to the 6, right? So 10 to the 6, we can do 10 to the 6 plus 1, but that will be 2. So we do this, it's like a prefix sum, on the number of servers that is alive. But what if we get 1 again? Huh? Yeah. What if? So what we want is count the unique number of servers in any given range. So we're given a range, right? We want to know how many unique servers there are. Given a range, I want to know the unique number of servers. I think prefix sum might not work. But hold on. You give me a time, right? I can binary search. So I can, from this going all the way to here, I know how many unique servers there are. Right? And then, yeah, in this case, right? So the first one is 5 to 10. So we need to know from 5 to 10 how many unique servers are between 5 to 10. So we say, okay, 10. At position 10 is basically here, right? So we say we have 2 unique servers. And 5, because it's inclusive, so I go 4. 4, 10 goes, this is 2. 4 goes, this is 1. We have 1 unique server. So in between, so all the way to 10, we have 2 unique servers. All the way to 4, we have 1 unique servers, right? Therefore, the number of unique servers between these is 1. But then it doesn't work for the second one, because the second one, you do 10, it will be 2, but you do 6, it will be 5. 5 will be 1, right? It will be 1. So you will say from 6 to 10. Oh, no. I was wrong. Now this is unique server. The number of unique, we want to have this empty. So it will be minus. But the first one is wrong, not right, right? Because 5, we do 4, so we have 1 unique servers. And then you will say you only have 1 unique servers, but actually there are 2, because 1 and 2 both are here, right? So that's why you cannot do it this way. Segment tree. Can we do segment tree on this? 10 to the 6, I guess it's fine. Well, if it's a segment tree, so if it's segment tree, we have the biggest range, we'll have the number of unique servers in this, that's fine. And then we do, a smaller range. So in the smaller range, we want to find how many unique servers is in this, right? So we have two operations. We have update and have query. So when we update, right? In this case, we update. We have a point of time, right? 5. We got 1. So we do 5, right? And then what we want is unique servers. But what type of data structure should be stored? It should be a number, right? But you do 5, and then you go this range, right? So I have a range, we do this 1. But what is the unique values in this range at that moment? Yeah, you do not know. You do not know. It can be a huge value. You can't just set up a... Yeah, you just... The thing is, if I know the number of unique servers, and I tell you this is the current server I have, you won't be able to know if this is already seen or not. And it's definitely not. I think it's gonna time out or memory timeout if I just use set. Like I just do a set. So you have to copy the set many times. I'm not sure. 10 to the 5th? If I have 10 to the 5th, then the biggest one will hold 10 to the 5th values. And each subsequent will hold, like half of the value. I'm not so sure about that. What else? What else can you think? Unique. Maybe we can do something with a query. If we do a query, we go query from small to large, right? If a query goes from small to large, maybe it can be something like a sliding window type of thing, right? So in this case, we start from 5 to 10. So we just count 5 to 10, right? We just go to 5. Yeah, because if we sort query from small to large, we always start from the smallest. So we go from 5, right, to 10. We do that, right? We do that. We do 5, so we have the index, and then we keep going until we reach 10, right? And then we count how many uniques. Then we have a set, right? We have a set to keep the unique ones in it. We run all the way to 10. Not really all the way to 10, but just, we just keep going until we exhaust, right? Until we exhaust the time point. Okay, so now we get 5 to 10. So we get a 5 to 10 value. So next we need 6 to 10, right? And we say 6 to 10. Next just based on what it is, right? Because X give you the range. The next one is just how much you move forward. So this need to move forward. So we basically just go forward and this go forward. Yeah, I think it's a sliding window. I'm gonna Python this thing. Okay, I'm gonna Python this thing because I need to practice. All right. Do you want to practice Vim? Well, should be practicing NeoVim, but I haven't set it completely up, so unfortunately, no. I will just never find time to really do this. I have other things at the moment that's occupying my time. It's bad. I know it's bad, but I have to do it. It's okay. It's all right. Just keep practicing the key bindings. It's never a bad thing just to keep practicing the key bindings. All right. So first of all, I need to sort logs. So we can say logs.sort key equals to, I need to sort lambda tuple, right, top1. So we sort based on this, right? This is very important. And, oh, I just used the arrow key. Damn. We need to sort the queries. So we need to say queries and index, right? Shall be sorted IQ in enumerate queries. We're gonna do QI, okay? QI. So now we sort it, it will be fine. So Q from small to large. All right, next we need to the result, right? The result. So rest shall equal to this. We just do 0, okay? Times the length of query. So len query, right? So this is the result, and we need to have a window. I'd like to handle the first one, because I think the first one will be different from the future. Maybe it's the same. Maybe it's the same, because when we get out, nah, I don't really think it's the same. No, it's different. Let's do the first one. Okay, let's do the first one, and we can say left and right. I mean, we can binary search, right? We can binary search, or we can binary search is log n. It's faster. So let's binary search. So we're gonna say left and right, right? So the first one, actually, let me just do this. We'll handle the first query, first sorted query, right? We're gonna handle the first sorted query. So this is going to be queries index what? 0, right? Queries index 0. 0 is a Q. So this need to minus X, and queries index 0 and 0. Okay, so that's the on the left and right. And okay, index equal to, let's do from bisect import. It's inclusive, so bisect left, right? Bisect left. So wherever we land on, because we're gonna sort the left, right? We're gonna sort the left. If it's in between, we're gonna go, yeah, bisect left is right. So we're gonna say bisect left queries index, no, logs, and key equals to lambda. Bisect left, it's this, and then left key equals lambda tuple. We are based on tuple 1, right? So that's the index. And then we say while, oh my goodness, that's just, while index is smaller than logs, len logs, right? Logs, and so we don't go over and logs index, because so I'm gonna implement an index, and logs index again. 0 is the query, right? 0 is the 1 is the time, right? 1 is the time. So we'll do that. The time need to be smaller equal to r, right? The right, because we index is the left, we find it, and then we keep going until we find, as long as it's smaller equal to this, we can do, and once it gets beyond, right? If we do something that gets beyond, and that's it. So we need a set. Okay, so we need to have a set is servers, right? Servers is going to be a set. And we say servers.add logs index 0. Okay, index plus equal 1. All right, they keep going, they keep going, keep going. Once it gets out, okay, once it gets out, I want this to, oopsie doozy, I think I need two things. I think this should be low, okay, and high will equal to low, and this is going to be, right, this is gonna be high, right? Next, this will be high, next will be high, this will be high. And once we're done, high or minus equal 1. So now low and high is inclusive of the first query. And then we say res query index 0 and 1, right? That will equal to n minus the LAN servers. Okay, so now we're gonna sliding window through the rest of the queries. For I in range 1 to LAN queries index. I think we can do, hold a second, I think we can do for query and index in queries index 1 to the end, right? I think this is, we're not copying anything. So we get a query, we get an I, and I want to know how many steps you have to go through. Yeah, so no, this is not right. That's okay. So has to go I in range 1 to LAN queries index. Okay. All right. So we can say delta, right? Delta is query index I 0, right, minus queries index I minus 1, 0. So this is the delta. So that's how much I need to move forward and move backwards, right? So what do? We basically say while low is so every time, so low, I'd say low need to move forward 3 steps. Okay, so low move forward 1 step. So we deal with this, move, deal with this, move, deal with this, move. 3 steps. So we get rid of 3. And oh, need to be a counter. Need to be a counter. Yep. Need to be a counter. So this is not right. It's fine. Let's get back here. From collections, import counter. Right. Oh, shoot, that's not right. Undo this. Oh, you undo the entire thing, dude. Redo everything. I can just do this and counter. Okay. And we're gonna change 911. We change this. This should be a counter, right? And not add. So this will just be servers. Probably call it something else. Let's call it something else. Servers count. Okay. Let's just call it counter. Okay, counter. So this is a counter. So logs this, we just do plus equal 1, right? And then while low is, it has to be smaller than len logs for sure. What if it go beyond? It's a good question. I have a window, right? What if it just go beyond? Well, if it goes beyond, then the previous doesn't work anymore. Then we should just bisect again. That's interesting. If it goes beyond, we should just bisect it. Then why don't you bisect every single time? Alright? You should just bisect every single time. You bisect it, you move through, done. Next one, you bisect, you move through, done. But it can be wrong. It can be wrong because it can time out, because it can just keep moving. Every time you have to move it. So yeah. So basically, the bisect has to happen very infrequently. I wish. Yeah. How am I supposed to do this? How do I know? It needs to. Well, if you're new, right? Yes. Okay. So I think we don't have to do it this way. Hold on. Let me change. But I think is this can be incorporated. So I'm gonna yank whole thing. Actually, it needs to be this. If there is no sliding window available, right? We bisect, we binary search, right, and iterate. Otherwise, we slide window this baby. Now, if we do this, then we should start from 0, right? And there's no delta. So we can just call. But we do need a low and a high previously. So we need a low. Oh shoot, we need to probably paste this. That's the part I don't like, at least at the moment. You just you have to have a very clear mind. I did not have a clear mind. I delete this, and I forgot to. No, that's not right. To paste this, right? All right, so that's not the thing. The thing is, we delete this. Sliding window. I want this. No, let's go up. Paste this. Let's repeat. Right, if we cannot slide window, use binary search and iterate. Right. And then otherwise slide window this. So we have a delta. Well, depends, right? Depends. Because I'm doing this together. Depends. If we might as well just do this separately. Yeah. I do think you should do it separately. We need a low and a high, okay? So basically we can say the current low, yeah, hold on. We can say low, high, plus minus 1 to start with, right? So delta so we have a delta, or we don't have a delta. Delta tell me how much I should go. Nah, let's not do delta. Let's just do current low and a current high, right? So we say current CL and a C high. C low and a C high. Current low and a current high, okay? Shall equal to, this is current low. Oh, That's not right. All right. So current low is this, but instead of 0, this is I. This is current low, and current high just this one I 0, right? So the current low, current high. Then it's the thing, if current low is larger than previous high, right? If it's larger than previous high, if not, we just keep walking. Because what I want is to not do repeated, right? Not do repeated. So if the current low is larger than the previous high, that means we will have to, or large equal to the previous high, right? So let's say if it's larger equal to the previous high, then we will do this. Current low, so this is current low, right? So I search for current low, and then we'll get an index. Wait a second, low and high is indices. Low and high is indices. It should be queries, it should be range. Range, yeah, range left and the range right. These are ranges. And this is range left. Right? What we get is ranges. Yeah, because this is our query, right? Our query. So this is a range, and oh my god, it seems like we have to binary search anyway. I think I'm a little bit confused. Okay, so we have range, right? And the range we can definitely find where it is right now in the indices, right? So the range can give me index to index, okay? And then if I have a previous one, if the indices are not overlapping, then we just do a new one. If the indices are overlapping, then we can just, move forward. Hold on. What we have is the ranges, right? We have the range, star, range end. And the range star, we're gonna give me an index. Range end is gonna give me an index. We can do 2, so give me the index. And we can produce the whole thing. All right, now we have a low and a high, right? We have a low and high. And next, the queries is different, right? The query is different. So the query will produce a new range, new indices, a low and high. And the new indices we will basically check. Maybe we can just negative it. It's fine. It might be fine. Because we just remove and we'll add it back. right? We just remove and then we'll add it back. So we remove, hold. So we remove everybody and then we get some negative values, all right? And then we will add everybody. So these will become positive. Yeah, it's just sliding window. We will have to, hold on, let me rephrase this. This is not right. Use binary search, right, to find the indices on logs. Then use sliding window to compute the counter. Okay, so counter is still right. Low and high is the thing, right? And basically we say from low and high, we'll remove that many, right? And we'll add that many, and then we'll add beyond. We'll remove and add, remove and add. Yeah, so I think this should start with 0. We'll do that. And we say current low is equal to, all right, this is equal to this, logs, and current high shall equal to bisect. Now this is interesting. Current high. Do we do bisect left as well? Well, if we don't do bisect left, we'll go to a further one. So we still do bisect left. So to be a right range, right, key equals lambda tuple 1 as well. Current low and current high, which pointing to, but hold a second, current high should be inclusive, right? Should be inclusive. So if we do this, we're actually landing at an index that is beyond. So I think this shall be right. Right, this shall be right. And I will -1 here, which means back here I need to do bisect right. Right? And then we'll say basically from low to current low, right? Low to current low, everything I encounter I'll remove, right? Everything I encounter from low to current low I'll remove. Remove all the way to current low. But we don't remove current low because current low need to be included. So we go all the way before current low, everybody in between, right? And then the next one from this to the new low, everything in between will remove. So I say for I in range from low to current low, okay? And I say counter logs I 0 and minus equal 1 for I range from high to current high. Now for current high, because low is inclusive, so we don't, high is also inclusive, right? High is also inclusive. And I need to add every single one from high. So every one encounter I'll +1, +1, +1. And I need to +1 current high as well. Right? I need to +1 current high because that's inclusive. So it'll be +1. And everybody I encounter, I 0 will be plus equal 1. We also need to go through the whole thing now. we shall count, right? Count. So res queries 0, 1 shall equal to n minus sum for value in counter.values, if I remember right. We do v is larger than 0. Okay, so that is the unique. How many times this has to be done? See, that is the thing, right? That is the thing. This might take time. I mean, on the outside, this is on already. This is the query, right? Query is on. How long is the query? Query is 10 to the 5th. And this requires 10 to the 5th as well, because we're counting. Because we could have, yeah, this will time out, man. I mean, if this will time out, these two will time out already. Every time you move, next time you move, I mean, it's because this is sorted, so eventually this will just move, this will just move towards the end. So this is fine. But this part, well, this part give me issue. Yeah, because you were doing the it might, man, it might. Because every time you do this, you go through this. This is fine because I'm just walking through the logs, right? I'm just walking through the logs. But each time I walk through the logs, I have a counter. And then the counter needs to go through this. I don't know. It's like if I can handle the values here, that will be more. That'll be better. So -1, -1, -1, -1. So we have a bunch of negative, right? And then I'll have a bunch of positive. Yeah, I think it's fine. I think when we handle the positives, we can say if it's equal to 0. But what if it happens again, right? What if it happens again? So that's really bad. Why don't we just try, you know? Just try. I'm not sure. So we return res. Hey, let's make sure this one works. I mean, I'm not even sure if it works. Does it work? Oh, I forgot the top. Nah, it didn't work. It did not work. Okay, so we now need to debug. It's more serious, the problem. Oh, what did I do? I think I typed something wrong. laptop. I think I typed. All right. Anyway, let's. No. Let's do 3, 1, 3. What's the next one? 2, 6, 1, 5, 5. Query is 10, 11. Answer should be 1, 2. Okay. Oh my goodness. Do this shall be n logs x queries. This is count. Oh no, count servers. N logs x queries. Ugh. Okay. The problem is the second one. Let's definitely we'll print logs. We don't have to print queries because queries we know it's sorted. Okay, logs is correct, and we need to print low and high. Let's take a look. 1, 2, 2, 2. That is correct. Okay, 2 to 2. And we probably need. Hold on. Let me do one more. Oh, that's not what we want. Oh. We do low high. Okay. Oh, I remember. I know why. I forgot to do one thing. After this done, low high should need to go to current low and current high. Huh! That's still not right. What? 2, 0. What? You gotta be kidding me, man. All right. Logs. Let me also print queries index. Just make sure this is right. Query index is correct. 0 minus this should be correct. This. So what we want is low high, previous low high, and current low high. Okay. The first one's not right. That is bonkers, man. That is bonkers. From low is 0, right? To this. So we have -1. Right, so 1 is, because we can only do one of them, right? We can only do 0. So logs 0, 0 minus equal 1. So 1 is -1. And then high is also 0, 0 to 2, including, so 0, 1, 2. So 1 should be 2, 2 should be 1. No, 1 should be 1, 2 should be 1. How is this not right? And minus. Okay, let's just print counter. Exactly. Counter is 1 and 2. And then say counter.values, right? V larger than 1, so this should be 2. N minus 2. N is 3. What? Dude, this is bonkers. Oh, damn. That should be I. Oh, Lord. This should be J. Oh. This should be J. Dear me. So this is J. This should be J. Oh. This should be J and oh no. J. There we go. So comment on this. Comment on this. And one more print. Okay. All right, let's try this one again. I mean, I think you were right, but I'm worried about this. I think I might time out. Yeah, I think it times out. We need to be smarter. Yeah, it's not working. Oh, wait, I thought timed out. What? 3,129 test cases. You are kidding. I've never seen so many test cases before. Alright, so we have a different issue. Oh, this is not one of those easy ones. Alright, let's handle this. It's okay. We can do this. We can do this. Let's do this. Down. Oh. Then it's this, right? And then this. And then what else? I need the answer. Answer is 2333. Ugh. Why am I not right? All right, let's. We need both. Okay, so we start from 11. What's x? X is 9. Okay, x is 9. So if we comment all this, that is not helpful. Let's do this. Oh my goodness. Okay. So we start 9. So it's 2 to 11. Okay, 2 to 11. So we got 2, 3, all 1. That is correct, right? And then the previous low and previous high I have. Next I go to 16, right? 16 minus 9 is 7, right? So we start from 7 is here, right? 7 to 16. So it's this to this, 1 to 1. 1 to 1, 3 becomes 2. I mean, it doesn't really matter, right? 3 becomes 2, but mine is still... Okay, 3 should not be 2. 3 should not be 2. Seven to 16, right? 7 to 16. So we go to 9. So 0 move to 1. So I remove this. Okay, that's fine. So we have 3 is still there, which is correct. And then for that should go from 1 to 1. Should go from 1 to 1. Hold on, let me think again. I think this probably shouldn't be high, because we're adding more, right? We're adding more, and the high is already added before, right? The high is added in the previous round, and in the current round I should not. So this I think should be +1. Yeah, I don't think it's gonna change anything, but it's actually making more wrong. Let me think. Yeah, because you do high +1, it'll be 1, and you didn't do anything. Right? Because to do 2, I just did this. Zero to one, right? 0 to 1. So on the low, don't remove anything, but on the high shall be from the previous high all the way to the current. So previous high, then you should need previous high to be on the outside. Okay, so we say, okay, so maybe we do, yeah, maybe we say low we start from 0, right? But high we start from -1 because I need a +1. Now we pass. Now we pass. How about the previous one? Hold on, I need this comment. Okay, try it again. Is it working? Nope. 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 Yep. Timed out. I think it's because of this. These, yeah, these can time out as well. I'm not even gonna try. How many I passed? 2,000. I mean, it's correct, right? But yeah, I was. So basically, we should not go through the entire thing. No, I mean, it's, how should I put it? If the low and the current low is very close, and if the high and the current high is very close, yeah, I think yeah, this is the issue, right? This is the issue. So whenever it becomes, whenever it becomes 0, I shall remove it. Whenever it becomes larger than 0, I shall add it. Okay, so you say we keep a track. Yeah, we have the counter, and then we say C. Okay, so C is the, let's call it the number, right? The number of servers that have received a message, right? So now when we do this, we say if counter logs j 0, right? We say if this is equal to 0, the first time it becomes 0, that is when I will reduce it, minus equal 1. Okay, whenever it becomes 0, right, it has to turn to 0. If it's negative value, I don't really care. And this is whenever it's equal to 1, right? So you reduce, right? The first time it becomes 0, then it's done. So you minus equal 1. And then now you plus. And every time you plus, if it's already in it and just getting bigger, so you don't care. What you do care about is something suddenly becomes 1. Yeah, so we say if counter logs j0, right? If that becomes 1, the first time it hits 1, that's when you say C plus equal 1. And I don't need to do this, so I can delete this. No, do not delete this. We need this. We just don't have to compute this. We say C. Okay, let's try it again. Let's run through this. Oh. Run through this. These are right. Oh, lordy. All right, let's see. Pretty slow. It might work. It might. Oh yeah. Terrible runtime, but it works. Oh God. Yeah, so my previous concern was correct. Right? It was correct. You can't just go run through the whole thing again. And I'm pretty sure there are easier way. I think I don't know. I don't know. Maybe we do one binary search. We don't need to do two. Because after you do one, right, you run through this, right? You do one binary search, you run through this, and you'd go, no. Then you have to run through the entire thing, right? That's wasting time. No, you go from the previous high and you just keep moving and until you hit. Yeah, because you have to run through this anyway, right? You have to run through this anyway. So this is not necessary. This is not necessary. Okay? This is not necessary. But this necessary. Maybe this is not necessary either. No, you don't need binary search. You don't need binary search because we have to go through this anyway. That is a very interesting idea. So what I'm saying is, okay, so hold a second. I need to record this. This is the first attempt, okay? This is the first attempt, so I want to give myself a recognition that this is the first attempt. Sort logs, right? Sort logs, sort queries, go from smallest query each time. Binary search. I typed search wrong. But oh my goodness, 2 times. Binary search on logs to know which range, right, to include. Then apply sliding window to find the count of servers that have received messages. So over log n with a sort, I mean technically we have n and we have queries. These are 2 different things. They're different things. So we have log.length, we have queries.length. Okay, so plus m log m. Okay, so we have that, and plus I mean that should just be the length of the log, because we only run the length at most twice. Okay, at most twice. That's actually not. No, that is right. At most twice, because we have sliding window. Yeah, so plus n, right? We can say where n is len logs and m is len queries. Yeah, basically this query doesn't really care. Okay, so this is our first approach. Let's try another one, which I think I can do away with. We can do away with. I think there is no need to do binary search at all, which means we're gonna remove this, okay, and we keep this, but J isn't gonna be range. Well, in fact, I think I'm gonna say J is equal to low, okay, while J is smaller than, of course, than logs, and logs J, right? Logs J, logs J1, it's smaller than range left. Logs J1 is the time on the log. So as long as it's smaller than the range left, we will remove, right? We'll remove. So these things will remove. Counter will remove, right? Up until now, after that, J will equal to the low, which is the current low. So we can actually go again, say low equal to J, right? This is the current low, because logs J1 is smaller than range left, right? Oh, and we need to do the J++, right? So when we exit this while loop, logs J is pointing to the first log, which has a time larger or equal to the range left, which is the next low, right? So we've done this, and we J again, J equal to high, right? Let's restate this. Just handle the low. Okay, so this we can say handle the high, right? Handle the high. Same thing. While J is smaller than that, logs, and logs J1 is, so we move to the right, right? Move to the right. The same thing, it has to be smaller than range right, right? It has to be smaller. If it's smaller than range right, then every time I encounter something, I can plus until I equal to range right. That's actually true. I think it should be equal to. You get equal to range right, because you hit range right, you'll still plus, then you'll go above, right? Then you'll go above. So with that, oh shoot, we don't need this. Counter will do this, blah blah blah, and here J plus equal 1, right? And then when it ends, high. See, maybe we should put high. We can do high equal to J. Like seriously, we can do high equal to J. So this, if high equal to J, we can just do high. So the high is 1 above, right? The high is 1 above. Then on the 16, I think we can go back to both equal to 0. What do you think? Right, so high equal to J. And then we do this. We don't need this. Let's try. Locally. Wait, I didn't write solution 2. Nope, you did not. Yep. Okay. So let's give this a crack. Let me delete all this unnecessary things. So this delete delete. Okay. Let's see if we'll get it any faster. Last time's 1,180 something milliseconds. Oh my god, it's forever pending. Oh my god. It's because I put the wrong stuff. Judging. I think it's I mean, it's I think it works. I think it'll be faster because we didn't do any binary search. Yeah, faster. We don't need binary search. But I feel like there is even a better solution. Ooh, actually, I think I write the big O wrong for this one. Yeah. This also has a log n, right? Yeah, it has a log n to it. But this is just, and this one doesn't have, just O n log n. Yeah, plus m log m and then plus n. This one is faster. All right. Thank you for the good wish. I mean, that will be it for today. That's already 1 hour. Not happy. I mean, this is 12%. Is not bad. This is bad. It's pretty bad. Okay, it's pretty bad. We're gonna deal with this tomorrow. See how other people do this. Sliding window. Maybe it is. It's just Python being slow. Oh, maybe it's also because they have increased the number of test cases. Yeah, that's more likely. But we'll deal with this tomorrow. All right, that'll be it. That'll be it for today. I'll see you guys tomorrow. Adios.